Okay, so for data gathering, we were capturing primarily Instagram posts using InstaLoader, so we discovered some limitations. Given Instagram is like a post-based or video-based platform, a lot of the content is actually in the image or the video. And given we were only getting the captions and the hashtags, like a lot of the information in the core trend sometimes wasn't not captured. And so to retrieve an adequate amount of data, we had to make up for it in volume. And for that, we had to use multiple computers for computation power. And some future improvements, we could add some sentiment analysis for emojis, or we could also try to grab the text from the videos or the images. We can also analyze comments to get more information about the topic that they're talking about. So for Instagram, we use a neural collaborative filtering approach, which is a hybrid model that essentially it regresses to figure out a predicted engagement score for a specific topic given an influencer, but is designed around a pairwise ranking objective. So what does that mean? It means that yes, it predicts a score, but also it uses the objective such that it learns to rank a positive sample. For example, a topic that did really well for a specific influencer, rank that higher than, for example, a negative sample, which is perhaps a topic that the influencer never interacted with or that did pretty poorly, relatively speaking. And so for that, we had 3 steps. The first one was data preprocessing and negative sampling. The second one was model building with a BPR objective, and the third one was training and evaluation. So for cleaning and preprocessing, it was really difficult. We had to remove unwanted symbols that could cause wrong inferences. A lot of times the post had mix of multiple languages, like one sentence would be in English, the other one would be in Korean, for example, and that made it really difficult for the embeddings to work. And we had to remove stop words, and we had to do encodings that are multilingual. And given each influencer post and a unique ID, and for negative sampling, we had to sample topics that a user has not interacted with, while also keeping in mind that it could very well be that it's just like in another language. In terms of model building, around a BPR objective, it was also very difficult. We had to construct a neural network model with influencers and content into a shared embedding space so that they could be related to each other in the model. We also computed difference for predicted engagement versus the actual engagement for each user item pair, so for each influencer topic pair. And then we use this difference to create the ranking-based objective, which, as mentioned before, is to learn to rank the positive sample higher than the negative sample. And for training and evaluation, we train the model using the Bayesian personalized ranking loss, which learns to rank positive items higher than negatives. And we evaluated its performance using the AUC ROC precision recall curves, and we visualized recommendations by manually testing on a few influencers just for sanity check. And here are results. The losses decreased pretty well over the epochs. I trained it over 100 epochs when I started realizing the validation loss wasn't getting much better. And here is the ROC curve and the precision recall curve.